AI can play a pivotal role in optimizing renewable energy sources by improving efficiency, reducing costs, and enhancing grid reliability. Here's how AI can contribute to renewable energy optimization.
Forecasting and predictive analytics. AI models can predict weather patterns with high accuracy, helping forecast solar and wind energy generation. AI can analyze historical and real-time data to predict energy demand, aligning it with renewable energy supply. Predictive maintenance powered by AI can reduce downtime of renewable energy systems like wind turbines and solar panels by identifying potential issues before they occur.
Smart grid management. AI can optimize the distribution of electricity by predicting and responding to fluctuations in supply and demand. AI helps manage energy storage systems, deciding when to store energy, for example, in batteries, and when to release it to the grid. AI can incentivize users to consume energy during periods of excess supply, balancing the grid. Maximizing output from renewable sources. AI-powered systems can optimize the tilt and orientation of solar panels in real time for maximum energy capture. Machine learning can analyze wind patterns to adjust turbine blade angles for optimal performance. AI can regulate water flow in hydroelectric systems to balance environmental impact and energy generation. Energy trading and market participation. AI systems can enable decentralized energy markets by predicting price trends and automating the buying or selling of surplus energy generated by renewable sources. Grid decarbonization and integration. Decentralized energy networks. AI can coordinate microgrids, integrating various renewable sources while ensuring stability. Carbon footprint reduction. AI systems can prioritize the use of renewable sources over fossil fuels by adjusting energy dispatch algorithms.
Battery management. AI can extend battery life by optimizing charging and discharging cycles. Integration of multiple storage technologies. AI can manage hybrid systems like batteries, pumped storage, and thermal storage to ensure efficient energy use.
Sustainability monitoring. Environmental impact analysis. AI can monitor and mitigate the environmental impact of renewable installations, such as the effects of wind farms on wildlife. Life cycle optimization. AI can help design renewable systems with sustainability in mind, ensuring materials are sourced, used, and recycled responsibly. Innovations in design and deployment. Smart site selection. AI can analyze geographical data to determine the best locations for renewable energy projects. Energy system modeling. AI can simulate complex renewable energy systems to test scenarios and refine designs. Real-world applications. Google's AI-powered wind energy. Google's DeepMind AI improved wind power output prediction, allowing for better grid integration. Tesla's Powerwall management AI algorithms optimize energy storage and usage in Tesla's home battery systems. AI in solar farms. AI-driven drones inspect solar farms for defects and inefficiencies, saving costs and improving output. By applying AI across these areas, renewable energy systems can become more efficient, reliable, and scalable, accelerating the global transition to a sustainable energy future. Please like and subscribe to our channel for more content on AI and renewable energy.